Today we're going to talk about an infinite geometric series. We're going to find the sum of that series. If you recall in lesson number 1, we talked about the idea of the difference between a finite series and an infinite series. An infinite series would be a situation in which you had, say, 2 plus 4 plus 8 plus 16 dot 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 dot. Okay, that dot 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 we talked about basically shows that the series is going to continue on infinitely. Another way that you're going to see the infinite geometric series is with the sigma. Okay, you're going to be able to recognize it by the infinity symbol that is above. So if you recall, when we talked about finding the sum of a series for geometry, and we did it with the arithmetic, this was our end value. But now we're going to have an infinite series. Well, there's two different types. A convergent series is a series that has a sum because it is approaching a specific value. If you see in this chart, okay, we have a starting value, but it is slowly increasing. Okay, but then it's basically, approaching a particular value. In this case, it might be like, 2 1/4. Okay, you're continually adding such a minuscule amount that it is not making it increase very much. So this is going to occur when the R value is less than 1. So you're talking about like 1/2, 1/3, 2/3. I'm not saying all fractions, because remember 4/3 would be greater than 1. So common example, if I were to take, say, 8 plus 4 plus 2 plus 1 plus 1/2 plus 1/4, okay, dot 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 dot. Your R value here is 1/2. Notice that if we start at the beginning, we have 8 plus 4 is 12, plus 2 is 14, plus 1 more is 15, then we get 15.5, 15.25. So the sum is slowing down. It's approaching a value. Whereas in a divergent series, say we kind of do the reverse of this, and we have it increasing 3 plus 6 plus 12 plus 24. 3 plus 6 is 9, plus 12 is your 21, plus 24 is 45, and if it keeps going, the value is going up and up and up and up, and it's never going to end. So in this case, if you have an R value that is greater than or equal to 1, you are not going to have a sum. Okay, so in this case, we're basically going to say that no sum exists. All right, let's take a look at an example down here. Okay, our first goal here is to determine whether or not it is convergent or divergent. And the reason is because if it's divergent, if it is going away, then there's going to be no sum for the series. But if it's convergent, there will be a sum. Okay, so if I take a look at the numbers that are presented in this geometric series, remember, if I want to find my R value, I can take the second term, divide it by the first term. 3 divided by 2 is 1.5. Now, since 1.5 is greater than 1, this is going to be divergent. That means that there is going to be no sum for the series. All right, so keep that in mind. In the second example, if I were to take my second term of the series, 50, and divide by the first term, 100, I get 1/2. This means that it is convergent, which means that there will be a sum, and we're going to show how to find that sum on the second page of our notes. Alright, time to stop the video and see if you can do example 3. Alright, now that you've had a chance to try it, this is a little bit of a trickier one. Okay, did this on purpose to review our dividing with fractions. If I take my second term, 9/8, and divide by my first term, 3/4, Remember that when you go to divide fractions, you take the first and multiply by the reciprocal of the denominator. So take the numerator, multiply by the reciprocal of the denominator. If I simplify this, I can multiply straight across and get 36 over 24. Both these numbers are divisible by 12, getting me a 3/2, which you see from example 1. 3/2 we already figured out is divergent, which means that there will be no sum. Alright, I'm going to go on to page 2. Alright, now that we understand the concept of a convergent and a divergent series, our goal now is to be able to find the sum. Well, for the divergent series, we already talked about the idea that no sum exists. And remember, that is when our R value is going to be greater than 1. I keep saying that, but remember, it's the absolute value is greater than 1. So if our R value is -2, the absolute value of -2 is 2, which represents a divergent series, and therefore no sum is going to exist. Okay? But if the absolute value is less than 1, then we can find the sum, and it's very simple. All we have to do is take the first term and divide by 1 minus r. So in example 4, very first thing I'm going to do is determine what r is. Since r is found by taking the second term divided by the first term, and I get 2, well, 2 is greater than 1, so therefore it is divergent, and that means that there is no sum. Second example on this page, example 5. If I were to take my 6/15 and divide by 2/3, we just did an example like this, numerator times the reciprocal of the denominator, multiply straight across, 18/30. Okay, if I simplify 18/30 by dividing by 6, I get 3/5. Okay, now that means that it is convergent. I can find a sum, and I'm going to find that sum by doing my first term divided by 1 minus r. Since my first term is 2/3, I'm going to take that, put in the numerator, subtract, and put it over 1 minus a 3/5. Remember that 1 is the same thing as 5/5, so 5/5 minus 3/5 is going to equal a 2/5. So 2/3 divided by 2/5, take the numerator, multiply by the reciprocal of the denominator. I'm going to do it a little different this time. I'm going to cancel out those 2's, and I get 5/3. That means that the sum of this infinite geometric series is approaching 5/3. That's my final answer. Okay. In example 6 that you see here a little bit lower, okay, we're using the idea of sigma. Okay, if you recall, when we talked about the idea of sigma earlier, we talked about the idea that the very first number that you see here is your a sub 1, and the number in the parentheses here is your r. Well, since I know that r is equal to 5 and 5 is greater than 1, this means that there is no sum. And the reason is because it is a divergent geometric series. Okay? But in example 7 that you see here, my r value is equal to 3/4. Since 3/4 is less than 1, it's convergent and I can find it. So the sum is equal to the first term over 1 minus r, or since 10 here is my first term, 10 divided by 1 minus 3/4, which is equal to 10 over 1/4. If I take my numerator of 10, that's 10 over 1, multiply by the reciprocal of the denominator, and I'm going to end up with 40. So our series here is approaching a sum of 40. Alright, so the big thing that you have to understand here in this lesson is the difference between the divergent and the convergent, and understand that the divergent series have no sum. Okay, this is the last section of the chapter. We have a quiz coming up and a test coming up as well. You know, there's not that many lessons, but there's a lot of different formulas that we've learned throughout the chapter. You need to know when to use what formula. So when we take a look at just even this simple one, you have to recognize, oh, I only use this formula when I want to find the sum of an infinite convergent series. Okay, whereas the other formulas that you've seen have been for the sum of an arithmetic, sum of a geometric, so on and so forth. Okay. Again, if you have questions, please come with them in class.